G'day and welcome back to Buildsum. And this time I want to go through the process of calculating the materials for your wall frames. So as you can see here, we've got a typical floor plan with the dimensions provided. And really what you want to do is for every wall frame, you actually want to go through and calculate every wall frame individually. I mean, there are some quick tricks that you could do, but it's a little bit more accurate if you do every wall frame individually. So obviously that's going to be a long process. It's not just going to take a couple of minutes. It's going to be quite detailed. So what I want to do, I'm just going to go through this example. I'm only going to concentrate on two wall frames. So this one here, which has just got all studs, there's no openings or anything in it. And this wall here, which obviously there's a window opening in that wall. So once I've done that, you could then go through and calculate the rest of the wall frames. And as you'll see, there's a little bit of work in it. So I've got wall 1 down here, no studs, no window, and wall 2's got a window. So the first thing we need to work out is our plates, top and bottom plate. And simply, they are just however long your wall is. So what I've also done before I started, I've actually gone through and identified how long I'm going to make my walls or where I'm going to join them. And quite commonly you'll try and join on an intersection. It's just an easy place to join them. Or if you can't join on an intersection, like down here, I've just nominated a spot just away from the window in the other wall, so I can just easily butt the two wall plates together. Okay, so I've worked out roughly where I'm going to join my wall plates. So the first thing, the plates, length of the wall, and obviously one plate at the bottom of the wall, one plate at the top of the wall. So for wall 1, it's 3.410 meters long. Obviously I'm just going to order 2 at 3.6, rounding that up to the next orderable length. And wall 2, 3.640 long, I'm going to order 2 at 3.9. Okay, so that's the wall plates. That's pretty easy. So the next one, and even easier than that, is the noggins. And for the walls that have got a window, because you don't have noggins running through the middle of your window, then the timber that would have been used for your noggins drops down and becomes your window sill. Okay, so as I said there, noggins, sills, and door trimmers. If you've got a door in the wall, the material that we're allowing would just get lifted up to the top of the doorway. So that's just easy. That's simply the length of the wall. Okay, our noggins are supposed to be in at every 1350 or 1.35 meters up the wall. So for walls up to 2.7 meters high, one row of noggins is fine. For anything above 2.7, you'd have to add in 2 rows of noggins. So you'd have to allow that row of noggins twice. But this wall, we've only got 2.4 meter ceilings, so we only need 1 row of noggins. So again, pretty similar to our plates. We just put the length of the wall in. Now, some people would say, well, why not just allow 3 lengths for our plates, which in a lot of cases you could do. However, your noggins don't have to be the same size as your framing material, your studs. They can be narrower. So in some cases, just better to separate that out. All right, but it's not that uncommon, quite common, to just allow 3 plate lengths to allow for your noggins as well. All right, so there's our horizontal members, our plates and our noggins, and our sill and door trimmers. Now let's have a look at our studs. Okay, so for our studs, the formula is the length of the wall divided by our stud spacing, 600 or 450, plus 1, right? Because when we divide wall by stud spacing, we're actually working out the spaces in between. And then if the wall has any intersections or any walls butting into it, we need to allow another stud for each intersection because we have double studs wherever the walls intersect. So for wall 1, 3.410 meters long divided by 600, our stud spacing, that gives you 5 point something studs. Now obviously you can't have a point of a stud, so we have to round that up to 6 studs. Then we add the 1 for the end, and with wall 1 there's no walls that butt into it anywhere. It actually butts into this wall, so there's no intersection, so we end up with 7 studs, and that means we would order 7 studs at 2.4. All right, we've got a 2.4 meter wall height. Our studs will be slightly shorter than that. Okay, I've got another video on that, and I'll put a link in the description. But for an orderable length, you'd have to order 2.4s. For wall 2, all right, 3.640 meters long divided by 600. Again, that gives you around 5 point something studs. So you're going to say 6 studs for that part of the equation. Plus our 1, that gives you 7. And then with wall 2, you have this wall here, it butts in there, and this wall here, it butts in there. So we have 2 intersections. So our 7 plus 2 gives us 9 studs. So 9 at 2.4 for our studs. So they're just our common studs. The other studs we have to worry about are our jam studs. And again, I'm doing the jam studs separately because commonly they're not the same size as our standard common studs. They could be, if we're using 35mm common studs, our jam studs might be 45mm thick. All right. And as a general rule, again, 2 per window. For every window, you'd put in 2, just allow 2 jam studs. If that window was, say, wider than 2.4 meters, I would probably allow 4 jam studs. All right, and the wider the opening gets, the more jam studs you're going to have to allow. By the time you get up to having to allow 3 and 4, then you've probably you have to do a little bit more research in the timber framing code to see just how many jam studs you would actually need. So as a general rule, for any window opening that's sort of less than 2.4 meters, just allow 2 jam studs per window. So obviously with wall 1, there's no window, so there's no jam studs. Wall 2, 1 window, 2 jam studs, and they're going to be the same length, even though they are going to sit under our lintel. You know, the chances of having a lintel that's wide enough to get us down to the next orderable size is pretty slim. All right, so we just order 2 at 2.4 for our jam studs. And the last thing we need to work out is our lintels. So the lintel sits over the window, and you're going to get given a window opening, or on your actual plan, they might just give you like a reference number, which you have to refer back to the window schedule to get your opening size. Okay, so that's the actual clear space that the window's going to fit into. Now, obviously, your lintel's going to have to be a little bit wider than that because it's got to sit on top of your jam studs. Okay, so in this case, I'm going to assume that my jam studs are 45mm wide. So I'm going to take the length of the opening, add 45 on either side for my supports. That gives me 90mm, and that will give me the length I need for my lintel. So no window in wall 1, so I don't have to worry about that. So wall 2, so my 2 meters and 8 for my opening, plus 90mm gives me an effective opening or lintel length of 2.098 meters. So technically, 2mm longer, you could order a 2.1. I'd probably personally round that up and order a 2.4 just to be on the safe side, just to have that little bit extra timber available if I needed it. Okay, so there you go. That's our major timber components that make up a wall frame. That's how we work out how many of them we need. Obviously, that's only 2 walls. You would have to go around and repeat that process for all the walls in your house, and then you could total up your orders and get that order into the timber yard.
G'day again, I'm back. Just to let you know, if you like this video, you can subscribe to my YouTube channel or follow me on Facebook so you don't miss out on more great videos.